So, what is a chromatography? Chromatography is a laboratory technique that used to separate and analyze the mixture of the substances into their individual components. So, this process involves the stationary phase, which is a solid or liquid material that is fixed place, while this mobile phase, which is a fluid that moves over through the stationary phase, which is we can see through the picture. As the mobile phase move, the components of the stationary phase react differently with the stationary phase and the mobile phase. So it will react, the causing of them is will react reflective affinities of each other.
Now let's move to the principle of chromatography. Chromatography is based on the principle where molecules in a mixture apply onto the surface or into the solid, and fluid stationary phase or stable phase is separating from each other while moving with the edge of a mobile phase. There are three principles of chromatography, which is sample preparation and application, development of chromatogram, and measuring retention factor value. For the first principle, sample preparation and application. A sample is dissolved in a volatile solvent and spotted using capillary tube on a line previously drawn on one end of the planar chromatography. For the second principle, which is development of chromatogram, all spots are allowed to dry first before it is dipped into the development solvent, which is a mobile phase. The development tank should be closed. This is to make sure that the spot move upwards and smoothly by capillary action without interruption. For the third principle of chromatography, which is measuring retention factor value. By looking to the picture, the distance the solid move, B, is measured at the center of solid spot or at its maximum density. By comparing the RF value of sample to that of standards, the identity of the sample can be determined. Sample with the same RF value with the standard confirm is present.
Absorption chromatography. To detect pesticide in food sample, we can use absorption chromatography, where the analytes are separate based on their different degree of absorption on a solid stationary phase. In absorption chromatography, a solid stationary phase with adsorbent properties is used to separate the components of a mixture based on their interaction with the stationary phase. The adsorbent material can be silicon gel, alumina, or other similar material. To detect pesticide in food sample using absorption chromatography, the sample is typically prepared by extracting the pesticide using an appropriate solvent. The extract sample is then loaded onto a column packed with the adsorbent material. As the solvent moves through the column, the pesticide interact with the certain phase to varying degree based on their chemical properties. Different pesticides will have different affinities for the certain phase, leading to their separation. The less strongly absorbed component will move through the column more quickly, while the more strongly absorbed pesticide will have a slower elution time. By analyzing the eluent at different time points, the presence and concentration of pesticide can be determined.
Classification of chromatography. Chromatography is divided into numerous groups based on various parameters. The fundamental parameter for classification is the chromatography method, which is column chromatography and planar chromatography. Each chromatography mechanism makes use of the mobile phase and stationary phase. There are three types of chromatography. The first one is column chromatography, the second one is paper chromatography, and the third one is thin layer chromatography. Related chromatography technique based on the application. To detect pesticide in food sample, we use column chromatography. High performance liquid chromatography HPLC crucial to maintain acceptable pesticide level below established level of safety for human consumption. HPLC is basically a highly improved form of column chromatography. Column chromatography is a method of purifying substance based on their polarity and hydrophobicity. In column chromatography, a stationary solid phase works with a liquid mobile phase to absorb and separate the substance moving through it. Compounds are absorbed according to their chemical composition, and elution is based on the differential absorption of a substance by the absorbent. In this type of chromatography, the setup stationary phase is located within a tube. The particles of the stationary phase, which is solid, are then made to fill the inside of the tube. The mobile phase is subsequently given an unconstrained one pass anywhere along the middle of the tube.
Hi, my name is Nurmania Biha and I will explain about the application of absorption chromatography, which is the detection of the presence of insecticide in fruit and vegetable using insecticide test kit. So firstly, an insecticide test kit obtained and unpacked. There will be test tube, an alcohol lamp, vials, tongs, test strip, acetone, glass slide, eyedroppers, capillary tubes, a color chart, and 2 bottles containing different test solutions, which will be used in the order described in the test kit's instruction sheet. Next, a sample of the fruit and vegetable that want to test for the insecticide residue were cut. A small amount of the fruit and vegetable, about 5 grams, placed into a test tube. 5 ml of acetone added to the test tube and a cap put on the tube and shoot it up to extract material from the fruit and vegetable sample. Next, the acetone of the fruit or vegetable extract poured into a vial. Using tongs, the vial head over an alcohol lamp to heat the liquid until it evaporates. Next, a drop of the test kit's first solution added to a strip of test paper with an eyedropper, and it set aside to dry. A capillary tube dipped into the vial holding the concentrated extract and used to place 5 drops on the treated test strip. The test strip sandwiched between the 2 glass slides and held them with tongs over the alcohol lamp for a minute. They will cool down for about 3 minutes. Next, the top slide lifted off and 1 drop of the test kit's second test solution added to the test strip. The color was changed. The test strip color matched with a color chart to determine what insecticide is present.
So, to conclude, the chromatography plays a crucial role, which has a wide range of application in various fields. Some common application of chromatography includes analyzing drugs, identifying additives, detecting contaminants, and analyzing biological samples such as blood and urine. These are just a few of examples of chromatography, but it has the ability to separate the complex mixtures, make it an invaluable tool in numerous scientific, industrial, and research disciplines. So that's all for us. Thank you so much.